Trigonometric equations and identities, page 1. A linear equation has one solution. What does that mean? Like if you have a linear equation and you put a value in for y, there's one x value which makes that happen. Okay. Quadratic equations can have at most two solutions. What that means is if you have a parabola and you want it to equal a certain y value, that can happen at most 2 times. Trigonometric equations have infinite solutions unless a restricted domain such as 0 is less than or equal to x is less than or equal to 2 pi is given. So, since you have, bumps, if you have a line which goes through one of the bumps, it's going to go through all the bumps. So then you would have infinite solutions unless you restrict the domain between here and here, for example. Okay? All right, let's look at the picture number 2. This is a cosine function. We're going to use this graph to graphically find solutions. First one says solve cosine of x equals 0.4. So we have the cosine x here. Let's draw a line 0.4 at about 0.4. And then we're going to find all the solutions from 0 to x equals 10. So how many solutions do we have? 1, 2, 3 between 0 and 10. We're going to find the solutions to 1 decimal place. I think that this looks like it's about, 1.2. X equals 1.2. This looks like it's about x equals 5.1. This looks like it's about x equals 7.6. And that's it. Just those 3 solutions. Okay. What about cosine of x equals negative 0.3? So negative 0.3 would be about there. Okay, so oops, that's about right. Okay, we're going to restrict the domain from 4 to 12. So 4 would be here, and 12 would be about here. How many solutions we have? We have 1, 2, 3 solutions. This looks like it's about x equals 4.3. This looks like it's about x equals 8.2. This looks like it's about x equals 10.5. So those 3 solutions. Okay. Next one, number 3. Use the graph of y equals sine 2x to find correct to 1 decimal place the solutions of sine 2x equals 0.7 for the domain 0 to 16. Okay, so notice that the b value is 2, which means that the period is going to be half as much as usual. So instead of being 2 pi, it's going to be pi. Let's see. We're going to draw this side of the equation, 0.7. Okay, sorry, it's not really straight. And then we're going to go from 0 through 16. 16's here. So that'll be how many solutions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 solutions. Okay. And let's see, this looks like it's about 0.3. This looks like it's about 1.2. This looks like it's about 3.5. This looks like it's about 4.4. This may be 6.6, 7.7, 9.9, 10.8, 12.9, like 13.9. Okay, so how many solutions is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 solutions for sine 2x equals 0.7. Now we're going to do sine 2x equals negative 0.3. Negative 0.3, it's about like that. Okay, so how many solutions here? Between 0 and 16 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. About 9. So this one looks like it's about 1.8. Maybe this one's about 3. This one looks like it's almost exactly 5. This one's about 6.1. This one's about 8.1. This one's about 9.2. Maybe like 11.1. 12.4. And 14.2. And one last one. 15.6. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 solutions. Okay. The graph of y equals tan x is illustrated. Use the graph to estimate tangent of 1. So tangent of 1. So tangent of 1 would be about here. The y value looks like it would be about, I don't know, 1.3. Okay. Check your answer with the calculator. Okay, so let's do that. Now this is obviously radians, right? So we'll go to mode, make sure we're in radians, quit, tangent of 1. 1.55. Okay. I guess my estimate wasn't very good, but okay. So with the calculator, it's going to be 1.56. And find correct to one decimal place the solution of tangent of x equals 2 for the domain 0 to 8. So tangent equals 2. So 2 looks like it's about there. And how many solutions? 1, 2, 3 solutions in that domain. It looks like one x value would be 1. Another x value might be 4.2. Another x value might be 7.5. Okay. All right. Just those 3. All right. And I think that's it for the graphs. That was page 1. Let's go to page 2. All right. So how do we use the calculator to solve similar problems? Basically, what we're going to do is we're going to take the left side, and we're going to put this into y1, and then we're going to take the right side, and we'll put that in y2, and we'll do second calc intersect. That would solve it. Of course, we'd have to do second calc intersect many times because you're going to have to do it once for each solution. Okay. Let's see. Let's do one. It's a little easier if we go ahead and demonstrate by doing. First of all, make sure you're in radian mode for any kind of graphing of trig functions. All right. So we are going to type in here on the left side. We're going to put that in y1, so sine x. We're going to put the right side in y2. And then we're going to graph it. But before we graph it, let's set the domain to be 0 through 12. That makes it a little bit easier to see how many solutions are. So we go to Window, and we set xmin to 0 and xmax to 12. For ymin, we could just put like negative 2 to positive 2. Okay. All right, and then it's going to draw in red, 0.431. And basically what we want to do is we want to find 1, 2, 3, 4 x-intercepts. I'm just going to show you how to do 1 or 2, and then I'm going to do the others offline. We'll check our answers, okay? Second calc intersect, which is number 5, and then when you do intersect, it's going to ask you what's the first curve, what's the second curve, and then ask you to guess. Now, first curve and second curve, when you only have y1 and y2 registered, you just hit enter twice because there's only two curves anyway. Then you move the cursor close to the intersection you want. Let's do this first one here. And then we press enter again, and it'll give you the answer for the first intersection on the left side. So the x value is going to be 0.446. Okay, and then we're going to do this one, and then this one, and this one. I'll do that offline, and then I'll write the answers down, and you can check your answers. Okay, so I'll be back. Okay, so the four intersections are 0.446, 2.70, 6.73, and 8.98. I gave 3 sig figs. Okay, next one, we're going to do 3 tangent x minus 2 equals 0. There's a couple ways you could do this. You could either put this into y1 and this into y2, or you could add 2 to both sides, and then you could put 3 tangent x on one side, and then you put plus 2 on the other side. Okay, but let's just make it easy for ourselves. We're just going to put this in the calculator. And actually, when it's equal to 0, you can use second calc 0 instead. So let's try to do that, just to learn how to do second calc 0 well also. So in the first, on the left side, I'm going to put 3 tangent x minus, and here I'm going to have to close parentheses. The other time I didn't even close parentheses because the calculator does that automatically for me. And then if I graph it now, oh, and that's the same window, luckily, right? 0 to 12. And now what I want to do is I want to see when it's equal to 0. I actually don't have to put in a second function that's y equals 0 into y2. What I can do now is I could use second calc 0, which checks to see when I have an x-intercept. When I do this, it's going to use the first function. And then I'm going to just move the cursor. And you can see the cursor right now is at 5. It's around here. Okay, it's off the screen, but I'm going to move it all the way over here to 1. So sometimes you're not going to see it, but sometimes you're going to zip through the screen, right? Did you see that? Zip through the screen. And I'm just going to, there you go. Okay, so I moved it slightly to the left of this first intersection. I hit enter. Move it slightly to the right of the first intersection, hit enter, and then I just hit enter again for guess. And my first value is going to be 0.588. Okay, and then I'm going to go do this one now. I'm going to repeat it. Second calc 0, which is number 2. And then I'm going to move the left bound cursor to be slightly to the left of the second intersection. It needs to show up here. Oh, there you go. Okay, and then enter. And then I move it slightly to the right of the intersection, enter, and then I hit guess. Before I hit guess, I don't even like change the position. I just 3.73. Okay, and now I'm going to go find this one. I'm going to do these two offline, and then I'll just show you the answers after I'm done. Okay, so using second calc 0, these are the 4 x-intercepts I found. Okay, and next one, solve for x on the domain -5 to 5. So here I'm going to have to change my window to be -5 to 5. So for x, remember, make sure you use this negative sign here. I'm going to change it to -5 to 5. And then I'm going to change my function that I'm graphing to 5 cosine x minus 4. And actually, maybe I'm going to need to also change my x min, x max. I mean my y min, y max, because it's very small. Let me put -10 to 10. -10. Then for sure, it's going to be fine. And then I'm going to put my function in here. I'm going to put 5 cosine x minus 4. 5 cosine x minus 4. From your experience in the last chapter, you can kind of predict where this is going to be. You know that it's like on the bottom side, right? Okay, and now what we're going to do is we're going to find these two x-intercepts here, this one and this one. Same thing as before, second calc 0 because we're looking for x-intercepts. Move the cursor slightly to the left of the first x-intercept. It draws a little boundary for you, slightly to the right. Enter hits the boundary, and then we just hit enter after guess, and it gives us an answer of negative 0.644. Negative 0.644. And then we're just going to go find this one, and then we'll be done. Second calc 0. And we'll just move it slightly to the right of this intersection, hit enter. Slightly to the left. So now slightly to the right, and then guess, and the answer is 0.644. That makes sense, right? Symmetric. Left one's negative 0.644, right one's positive 0.644. Okay, now we're gonna do one that's 8 sine x plus 3. So 8 sine x plus 3. 8 sine x plus 3. Let's graph that one. Okay, this one kind of goes off the screen, but it doesn't matter because we just want the x-intercepts. Looks like there's 3 x-intercepts, right? 1, 2, 3 x-intercepts. So same thing with this one. We're just going to use second calc 0. Since the right-hand side of the equation is always 0, we just do second calc 0. We don't even need to put a y2 function in there. Now we do the right bound, and then we hit guess. It's negative 2.76. Remember last time we did guess, I just told you to hit enter 3 times, right? When you did second calc intersect, for example. These guesses, it matters, right? You need to put the cursor kind of close to it or the boundaries around it, because otherwise, how does it know which of these 3 solutions you want, right? So my first one is negative 2.76. Let's do the next one, second calc 0. So I'm going to have to move the left boundary kind of close to the next x-intercept. Then I move it to the right, hit enter again, and then I hit enter for guess, and it's negative 0.384. And then I'm going to find this one over here. Okay, so we do second calc intersect number. Not second calc intersect. Second calc 0, number 2, and then I move the cursor to the left of this third intersection, x-intercept, and then I move the cursor to the right, hit enter again, and then when it says guess, I just hit it one last time. The answer is 3.53. So those are my 3 solutions for 8 sine x plus 3 equals 0. Okay. Now, let's see, we're going to solve now for the domain 0 to 2 pi. So remember, 2 pi is 3.14 times 2. So I'm going to put the left side is this, and my right side is this, and then I'm going to set my window to 0 to 2 pi. Let's do the window first. So for the x min, I'll put 0. For the x max, I'm going to put 6.28, which is 2 pi. I can actually type out 2 pi if I want to. I'm going to do that. 2 pi. And then I could go to my y equals, and then I'll put in the left side of my function, which is sine x plus 2. Remember, all these are being graphed in radian mode. X plus 2 plus 2. And then the other side of the equation, the right-hand side of the equation, is 0.0652. 0.0652. And I'm going to graph that. I forgot to, oh yeah, I already did the window, right? I did from 0 to 2 pi. Perfect. Okay. All right. So the red line is very close to the y-axis, especially because I have probably my y-scale not appropriately scaled. You can't really see that the red line is slightly above the x-axis. Okay. So we're going to do second calc intersect. And since there's only two functions in my y equals screen, I don't really need to be that careful except for the guess, right? So first curve, second curve, I just hit enter, enter. It says, is it the blue function? Yes. Is it the red function? Yes. There's only two functions, okay? Then it asks me for a guess. I just need to put the cursor relatively close to the first intersection to find that one. And it says it's going to be 1.08. 1.08. Okay, let's do this one here now, and then we'll be done. Second calc intersect, then enter, enter. Blue function, yes. Red function, yes. And then I just move the cursor a little bit more closer to the second one, and I hit a yes for guess, and it tells me the other one, which is going to be 4.35. Okay, so those are the two solutions for part A. Well, now look at C. C is quite challenging. It's got two very weird looking functions. Like the left side is not just a tangent function. It's got x times tangent, and then you got x squared minus 10 inside x squared. Oops. X squared divided by 10. Just to test it out, let's make sure. Okay, no, it didn't. Something I did, all those backspaces I did. Yeah, see what I did there? That's bad. Okay, maybe now it's okay. Okay, now it's okay. Be careful when you start deleting stuff. Sometimes you can't see that there's garbage there. Okay, there's my tangent function. All right, my x times tangent function. Okay, that's a pretty weird function. For y2, I'm going to put the right-hand side. The right-hand side is x squared minus 6x plus 1. What kind of function is that? Yeah, it's parabola. Plus 1. Okay, and then my window, luckily, is still 0 to 2 pi, so I don't need to adjust that. Oh, interesting. Okay, so there's two intersections. There's this one and this one, right? So we're going to do second calc intersect, which is number 5. And then basically, I just move the cursor kind of close, and then I hit enter 3 times, right? First curve, blue, yes. Second curve, red, yes. Guess. I get kind of close to it, and then it says the answer is 0.171. 0.171. We don't even need the y values because, the y value is 0, obviously. Now you say, this isn't 0. This is 5 times 10 to the negative 4th. Okay, it's 0.0005. You see the way the calculator solves this is not, analytically, so it doesn't actually get 0. It gets some weird number, right? Let's grab this one now. We're going to do second calc intersect again. And then enter, enter. And then for the guess, we do need to put the cursor close to the guess. When you do the first two enters and you accept that the blue function is the first function and the red function is the second function, you don't need to get the cursor in any specific position. And then my answer is 4.92. So those are the two answers for that one. Number 4, solve for x. And this one is a little bit different. So first of all, let's set the window, -2 to 6, window. And I'm going to put -2, and then I'm going to put 6. And then I'm going to type this left side and this right side into y1 and y2 respectively. Since that's going to take me a little bit of time, I'm just going to pause and I'll come back to you in a second. Okay, I think I typed it in okay. This is actually a cubic function, right? I'm going to graph. Oh, did I already set the window? I did. Okay, so I'm just going to graph. Here's my left-hand side function. The blue function is the y1. Whenever you have a color calculator, unless you change the colors, the blue function is y1 and the red function is y2. And There we go. So there's 1, 2, 3 intersections, right? So let's do the first one. Just put the cursor close to the left one, and then we'll hit enter 3 times. Enter, enter, enter. And the answer is negative 0.951. Negative 0.951. And now let's do the second one. Second calc, intersect number 5. Just move the cursor close to the second one and hit enter, enter, enter. The intersection point is 0.234. 0.234. And last of all, we're going to grab this one, which looks like it's barely in the interval. Enter, enter, and then we move the cursor. Unfortunately, I'm on the red function, so it has disappeared. Eventually, it will. There we go. That's close enough. Enter. And so the intersection is 5.98. So that one is within the boundary also. Final section. Okay, you can always find a decimal or numerical solution of a trigonometric equation using a calculator, which we just did. If the solutions are multiples of the special angles like pi over 6 and pi over 4, you can always find an exact solution using algebra. This is called an analytical solution. We use the periodicity of the trig functions to find all the solutions in the specified domain. Remember that sine x and cosine x have period 2 pi and tan x has period pi. Consider sine x equals 1. We know that one solution is pi over 2. What are the 3 other solutions? Okay, or what are 3 other solutions? Okay, so sine x, between 0 and 2 pi, the only solution of sine x equals 1 is pi over 2. But if we just add repeatedly 360 degrees or 2 pi to it, we can generate more solutions. Okay, like, and then we can also subtract 2 pi from it. So these are 3 more solutions. We can simplify the fractions, but basically we're going to add 2 pi, add 4 pi, subtract 2 pi. Those are 3 more solutions other than just plain pi over 2. Okay, write the general solution using the integer k. So we could just say, oh, actually, all solutions would be pi over 2 plus k 2 pi, where k is an element of all integers. Okay, now we're going to do a couple simple examples of trig equations. So instead of the old days where we usually just look for solutions between 0 and 2 pi, to make it a little bit different, we're going to do between 0 and 4 pi. So we're going to find the solutions between 0 and 2 pi, and then we're going to add 2 pi to find any other solutions. Okay, so they didn't give it to us straight. Look at that. They didn't isolate cosine x equals something, but all we need to do is do a little bit of algebra, and then we can find what cosine of x should be equal to and solve it analytically. Divide both sides by 2. So actually this is basically the same thing as saying that cosine of x equals 1, I'm sorry, not 1 over x, 1 over 2, right? Cosine of x equals 1/2. Now we know why we memorize the unit circle. We need to know what possible angles have a cosine of 1/2. That would be this triangle or this triangle. So that would be pi over 3 and 5/3 pi. These are the 2 solutions between 0 and 2 pi. If we want the solutions between 0 and 4 pi, what we do is we add 2 pi to this one, and we add 2 pi to this one. So if you wanted to do the fraction math, this would be 6/3 pi plus 1/3 pi. That would be 7/3 pi. And then this one would be 6/3 pi plus 5/3 pi. That would be 11/3 pi. So those would be 2 more solutions in addition to the first 2. Okay, so that would give us all the solutions for 0 to 4 pi. This one here, tangent of x equals pi. Let's see, between 0 and 2 pi, tangent of x is equal to 1 a couple times, right? At like 45 degrees and at 225 degrees. So in radians, that would be pi over 4 and let's see, would that be 5/4 pi? Yeah, 5/4 pi. And then, of course, there's two more solutions between 2 pi and 4 pi. All we need to do is add 2 pi to each one, and that will generate two more solutions. Oops, 5/4 pi, and this would be 2 pi here. So pi over 4 plus 8/4 pi would be 9/4 pi. Is that right? Yeah. And 5/4 pi plus 8/4 pi would be 13/4 pi. So we would have this solution, and these two solutions. Those would be the four solutions for 0 to 4 pi. And that's it for page 1 and 2. Sorry it was so